Integrating application containers with VMware vSphere. Application containers are promising because they deliver portability and increased agility for developers. But native Linux containers may not satisfy the isolation and resource management requirements for production. Virtual machines offer proven security and performance isolation benefits, which is why it is typical to see containers running inside dedicated VMs today. But deploying containers in this fashion introduces overhead that wastes resources. Imagine a platform that offers the agility of containers with the isolation and manageability of VMs. Project Bonneville turns your trusted VMware hypervisor into a container host, where VMs are the containers. What you're about to see is a technology preview that showcases the agility of containers with the robustness and flexibility of VMware virtualization. In this environment, we have an instance of Bonneville integrated with a standard VMware ESXi host, and we're managing containers through an unmodified Docker client. Let's start off by pulling a couple of container repositories from the public Docker Hub to ensure we have the latest version cached. Just as each Docker container host typically has its own cache of container images, Bonneville leverages a single image cache for all of the container VMs in an environment, saving time, bandwidth, and storage space. Now that we have some images available, let's do a simple interactive demo with an Ubuntu container. When a container starts, the live Photon-based VM is forked, using instant clone technology that was introduced in vSphere 6 to dramatically reduce the resource footprint. Testing shows that Bonneville containers are currently far closer in memory footprint to native Linux containers than to VMs. When a container stops, the corresponding VM is powered off. The container can be restarted as needed, just as with native Docker containers. By the way, the Bonneville containers shown here leverage a Linux kernel derived from Project Photon, the small footprint container runtime from VMware. Removing a container deletes the underlying VM. Notice that the container ID correlates to the VM name. Next, we'll show that Bonneville offers API compatibility for more complex use cases as well. Here, we're using the Docker Compose sample app, a simple Python and Redis web application. After the two container VMs start, they're linked together so that the Python web app can increment a simple visit counter in the Redis database. API compatibility with current and future container ecosystem elements opens up infinite possibilities for agile teams to integrate Bonneville into operational workflows. Agility plus isolation for the best of both worlds. Project Bonneville delivers the container ecosystem you love with the VMware infrastructure you trust.